Okay, so we're going to prove this argument using the unit circle to show that the squeeze theorem and the sine of x over x limit is 1. So drawing this out, we have this arc length right here, and we're going to connect these lines to create two separate triangles, and we're going to encapsulate the area of the arc length in between these two triangles. So we have this length x here, or sorry, z, I'm just going to call it z. We have our angle x. We have, this is going to be 1 from this length right here up until there. And then this part right here is going to be 1 as well. So using that, we can see that z is going to be sine x if you look at the small triangle with just sine properties. And w for the bigger triangle will be tan x. So using those, we can generate the area relationship for all three shapes. So for the first one, we're going to have that 1/2 of sine x is going to be less than or equal to x over 2 from the area of an arc length, because that's technically a circle. It's just a piece of a circle, so that's how we end up with that. And then we have 1/2 of tan x. Now we can do some simplification here. We can multiply everything by 2. So we end up with sine x, which is less than x, which is less than tan x. Now we can do another form of rewriting. So I'm just going to write sine x less than x, which is less than sine x over cos x. Now we could multiply everything by cos x, but instead I'm going to multiply everything by, or divide everything by sine x, sorry. So we end up with 1 on the left, which is going to be less than or equal to x over sine x, which is less than or equal to 1 over cos x, which is, I can just write it as this instead of secant x, so it's easier to look at. And now when you reciprocate everything, you have to flip the inequalities, so we're going to end up with this. So reciprocating this, it's just going to be cos x actually anyways, so I didn't write the secant of x for a good reason. And now this is just simple squeeze theorem. We have what we want in the middle. We can evaluate the two limits on the left and right, and we know that they're greater than each other as the sequence of inequalities shows. So we can just do the first one. The limit as x approaches 0 of 1 is just going to be 1, and the limit as x approaches 0 cosine of x is going to equal 1 as well. So since 1 is going to be sandwiched in between this limit, we draw the conclusion that this limit is going to end up equaling 1. Now this limit is also going to be used to prove the other limit with cosine in it, and that's how we will derive that equation.